My name is Prashant Sharma. I am a member of the marketing function at Hirist and jobs.com. Hirist.com is one of India's largest portal for tech hiring and for job seekers, for engineers. If you're a great software engineer, you're obviously on Hirist, and also, which is why you also taken time out to attend a webinar on a topic that is from programming to engineering. It is a topic that would actually help you also understand aspects that you maybe do not encounter on your day-to-day basis, but it's something that you would definitely be interested in the near future. Just to give you a little bit of a context, the Hirist Tech Talks are an initiative that are aimed at ensuring that we all have intellectual engineering conversations going on. Firstly, I hope all of you are doing safe, all of you are healthy. These are, of course, troubled times, and during these times, I hope you're all surrounded by loved ones, taking all necessary precautions, and I hope you all are wearing your masks. Wearing masks is very necessary whenever you step out. So I hope through all of this, you're able to do these things well. We, of course, aim through this initiative to bring the tech community together and create content for the tech community. Today, our topic is around from programming to engineering. Now, for me to talk about this topic would actually not do justice to it. So what I will do is I'll talk to you about the panelist, because I've had the pleasure of connecting with Arfat for a while now, and he's someone who's extremely passionate about JavaScript and its ecosystem. He's currently the director of education at Pesto Tech. Mr. Arfat Salman is also someone who as an instructor has taught React, JavaScript, and web development to more than 500 students. So trust me, you're in good hands now for the next 1 hour or so. Arfat has he's been in charge of architecting, developing, and improving multiple React applications, fully tested with Jest and Puppeteer, as he says, with backends in Node.js and Flask. As one of the founding members of Pesto Tech, he serves as the director of education and the lead instructor. And this guy actually he eats, sleeps tech as well, because in his free time, in his spare time, he also likes to talk about functional programming, language design, and system architecture. Once again, we're very, very happy to have you here. And me, Prashant, will now take a backseat, and I'll hand it over to Mr. Arfat Salman, who will be sharing his screen as well. Guys, have a great next 40 minutes, because I'm telling you, it will be definitely worth your time, right? Thank you so much.
Thank you, Prashant. So can everyone see my screen? Just raise your hands. I can see a couple of yes. Thanks a lot, guys. Thanks a lot for coming in, taking out the time on a Friday evening, right, and listening this conversation. Thanks a lot, to Hirist and Prashant for helping me arrange all of this, right. It took a lot of effort to kind of get this going. So thanks a lot in attending this. Anyway, I just want to tell you what you are going to get from this conversation, right? The topic is from programming to engineering, right? So why do I want to talk about this topic and this topic only, right? Why not some other topic, right? So I have been an instructor since quite some time now, and I have seen that a lot of students, especially in India, they have a different view of programming, where it does not align with, for example, let's say good product companies in India itself, or for example, in US or European markets, right? And they have a different conception of what code, what programming, what engineering looks like, right? And that is what I'm trying to kind of going to tell you today, right? Like, what are they looking for, right? And whether what they're looking for is actually a good thing or not, right? Because again, it may not necessarily be that whatever they are looking for is the best thing, right? But it can also mean that maybe we are deficient in some things that we can probably learn from, right? So in this case, when I say from programming to engineering, I don't want to say that programming is bad, right? No, programming is actually pretty important. But then how can you be a programmer and then you can also be an engineer? How can you switch gears at times from your programming mindset to your engineering mindset, right? We're going to also talk about some examples on this itself. So let's proceed by talking about what programming is, right? Just a very quick definition. I am pretty sure all of you already know this, right? But a programming essentially is a process of designing and building things for the computer, right, that serves a very specific task, right? For example, you want to fetch some file, you can write a script, right? You want to, have a clock on the web, right? Like somehow, so that you can write a program for that, right? And that is programming, right? The programming essentially involves that you have some very specific agenda, you use some language, right, some process, and then you achieve the agenda. That's it, right? And that is what programming is. If you think about this, it is like cooking, right? When we are cooking, right, you guys are cooking, I'm pretty sure a lot of you must be cooking nowadays because things are shut down, right? So you have a ton of ingredients in your kitchen, right? And at times you cook, right? You cook food, it may be good, it may be bad, but you cook it, right? And that is essentially what programming would be, right, in that sense. But what is engineering? So here is one definition from Google's software engineering department, right? So they say that actually engineering is not just the act of writing code, which I would assume is programming, but engineering also involves all the tools and processes that the organization uses to build the system and to maintain the system over a period of time, right? So they describe this thing as programming integrated over time, right? So essentially multiple iterations of programming where there is more emphasis on tools and processes, right? Some soft skills sort of a thing. That is what an engineering would look like, right? So taking my cooking example, you can think of programming and engineering roughly in this term, right? A programmer would correspond to somebody who is a cook, right? The cook may really be a good cook, but then you would not call that cook a chef, probably, right? There is a difference between a chef and a cook. How many of you think that, okay, there is maybe slightly some difference between a chef and a cook? Just raise your hands. Okay, I see a lot of people are actually 10 attendees have raised their hands, right? Right, 9, 10, that's the average I'm getting, right? So more people are coming, some people are lowering their hands. I think that 10, 12 people, 15 people, I guess, are saying that, okay, there is a difference, slight difference. And that is what I want to think, right? What I want you to think. If there is a difference between a chef and a cook, when the underlying activity is essentially the same, what is the difference? Think about that, right? Think about a person who sings in their house, right? For their friends, they're a bathroom singer sort of thing, right? They have good voice. And think about the difference between a professional singer, right? Do they have the same kind of issues that, let's say somebody who is singing for passion, right? How many of you actually drive bikes, right? Like they are very good drivers. People will your friends will tell you that, that, okay, you are a definitely very good driver, right? So how many of you know how to drive bikes, good bikes? You have bikes, you are a bike enthusiast, right? And you drive very well. You have gone for long trips, right? Let's say. How many of you here? Just raise your hands. Okay, cool. 7, 8 people are into bikes, right? Now the thing is, would you think of yourself as a bike racer, a person who drive bikes for a living professionally in a race track, right? Circuit sort of a thing. Do all the people who raised their hands when they were driving bikes, do you think you guys would also categorize yourself as a racer, a professional racer? Again, you can raise your hands, right? I think one person is raising hand, and maybe it was from the previous one, right? So, or maybe they want to categorize themselves as racer, right? So again, as opposed to the previous answer where there were 9 or 10 people saying they would drive, right? One or maybe 2 people are saying, okay, they would probably categorize themselves as racer, right? Because that's not what we do. Even if the underlying activity is the same, right? We do not think of ourselves as professional racers when we are driving on the road, even if we are really good driver. That is roughly the difference between programming and engineering, right? It's nothing bad, but again, there is a difference, right? That's what I'm trying to say here. Now, you can be a really good programmer, and then you can also be a bad engineer. So there is something that you definitely have to go from programmer to an engineer, right? So you can go from programmer to engineer, but being an engineer is not an isolated activity. You have to be a programmer first to become an engineer, because as you saw in the definition, engineering involves programming integrated over time, right? Which means that you have to focus on making sure that the things that you write are not in isolation. They are somehow tested. They are well built, documented. They work correctly across platforms for all users, right? So you have to go back to programming at times, and actually it's a cycle. You are sometimes programmers, you are sometimes engineer. The issue happens is when you are not able to context switch at the correct time, right? Sometimes you are programming, but then you have to switch, but you don't switch, right? And that is not something that is good. That is not something a lot of product companies actually want, right? For example, when you go to interviews, they expect you to actually behave like an engineer as opposed to a programmer, right? They don't just want you to solve an issue, right? They want you to think of an engineering solution that can be scaled, that can actually work for a lot of users and stuff, right? So let us talk about tools for the first section, right? I have 2 or 3 other sections. We're going to talk about tools, and tools are really important. I'm going to talk about programming languages in general, right? And why people kind of get attached to programming languages, and how to kind of think of these things as mental boxes, for your design process, right? So you can read the code, you can read the comic, right? Again, I have taken these things from the internet. I'm pretty sure you may have seen some of these things previously also, right? So how to identify yourself that you are in the programming mindset with regard to tools, right? There are a couple of statements. If you say yes to any one of these statements, you are probably in the programming mindset, right? And again, it is not bad to actually say that, right? To say yes, right? So again, you should not be saying the wrong answer just for the sake of, let's say, giving a correct answer, right? But what if this applies, then you should think that, okay, can I do something better with regard to this, right? Do I have to change my makeup or something, right? But one important thing is that, have you heard this statement, right? Like somebody saying to you, or you saying to somebody, if you know C++, you can learn Java in a day or in a week or in a month, right? Have you heard this statement before? Maybe somebody has told you, maybe you have told to somebody, and it doesn't have to be C++ and Java, but it can be anything. It can be like, okay, if you know Java, you can learn C# very quickly. If you know Java, you can learn Python very quickly. If you know JavaScript, you can learn C++ very quickly. Like one of these combinations, right? How many of you have just raised your hands? Okay, 7, 8, 9, 10. Okay, I think 8, 9 people have raised their hands, right? One person also raised their hands on chat. Thank you. Thanks a lot for your responses, guys. So the thing is, this obviously is talking about the programming mindset, right? So this is one. I'm going to come to this, right? What about this? Again, this is a general format where if you know X, you can learn Y very, very quickly, right? The statements are of this kind. What about this meme that people share on the internet? You may have seen, right? A lot of people sharing this, saying, okay, probably, it aligns with me, somewhere on LinkedIn, somewhere on Facebook, somewhere on other websites, right? Like, you have this, yours is without a doubt worst could have run, but then the other guy says, okay, but it actually runs, right? How many of you have seen this code or think that, okay, this is something that I align with? Okay, definitely fewer people than the first one, right? Right, and again, this is also something that speaks about the programming mindset, because this is probably not the best mindset to have, because if you just think about this from some other perspective, you will see that how quickly it falls apart, right? Think about a restaurant, right? You go to a restaurant and you ask for biryani, and they bring you the worst biryani you have ever eaten, but in the end they tell you, but it's edible, right? Why do you want to worry about taste? You will eat and you will not die, right? It's edible. So why are you complaining, right? That is what it sounds like when you say, the code runs, right? The code running is like the most basic thing you can do to the code. And definitely you have to step up from that. You cannot go below that, right? There are more statements, right? Language X framework Y is the best. There is a conception of some language, some tool being the best, in general, right? For example, a lot of people who know one language, they tend to think that, okay, maybe this language is the best, right? There is also this other conception, right? Where you say, okay, I know Java, so I'll learn C# now, right? Or you're trying to learn a new language, but then you're not sure how to kind of go beyond my current bubble, right? So that is one. There is one more very interesting one, and this is something that is very, I guess, something you have seen a lot in memes, right? If it doesn't work, I don't know why it works, and I still don't know why, right? How many of you have seen this thing and kind of align with it sometimes, right? Okay, it happens. Right. 5, 6 people are saying yes, right? 6, 7, okay, 8. Yeah, right. So again, number of people who are, so again, guys, feel free to raise your hands, right? In case if you think or, align with these things, because it is important for you to actually think on these lines, right? Perfect. But again, this is talking about the programming mindset, right? You're not really understanding what is happening, right? Maybe because of time, maybe because of some other issue, right? So we are going to worry about this concept of expressing programs, right? So if you think about this, in the comic, we just saw that, in the meme, we just saw that there are, you can do something and this thing can actually work. But the fact that something works is not enough, right? It is never enough. You can go to a restaurant, like I said, right? They can give you bad but healthy food, and that would not be enough. You want presentation, right? Right? You can go to a bike showroom, right? And then the bike can technically be like a scooty of a sort, or Luna or something, very old bike. And the bike will take you from place A to place B, right? Or point A to point B. But that is not what you want in a bike. Obviously, the fact that the bike runs is actually given. But everybody looks for more things beyond the bike, beyond the fact that it is running. Yes or no? Do you go to a car showroom? Do you just ask the salesperson, does the car run? Or do you ask other things? Just raise your hands if you ask other things. Beside the fact that it runs, actually, like it works. Okay, 9, 10 people are saying that they ask other things, right? If you think about this, isn't it hypocritical, to say that, okay, if my code runs, that's fine. But if I go to some other product, right, the fact that it runs is not enough. I want to have efficiency. I want to have, good comfort in the seating area. I want to have more seats. I want to have a good hatchback. I want to have, some other radio system, music system, right? Why, right? Why does your code can just run and things are okay, but you go to a car showroom and all of a sudden the fact that the car runs is not important, right? It's because we are not thinking of our code as products, right? We are hypocritical to some extent, right? And this is what expressing programs look like. There are multiple ways of expressing the same solution. Which one is the best one? That's what we're going to focus a little bit of a time on, right? You can read this particular thing, right? And you can see that we are trying to convey the same concept across this, right? Across all the text, we are trying to convey the same concept, right? And the thing is, how many of you, after obviously take 10 seconds to read it, but you will see that you're not getting more information, right? You are getting the same information as the first one. I can't, right? How many of you would prefer the dissertation way of saying I cannot do something? How many of you would prefer that? Just raise your hands. Okay, Nilesh would prefer the dissertation version, right? Really, really verbose, Nilesh. That's cool, right? One people are right. How many of, so now let's go to the other extreme. But how many of you would prefer the first one, the chat icon? Okay, definitely more number of people, right? 5, 6, 7. Okay, cool. Chat, but Siddharth also says chat, right? So again, the chat is short, it is concise, it is succinct, right? It conveys the same amount of information, right? And if you think about this, that is what we can do to our programs also, right? We can actually at times write stuff and we may not realize it's extremely verbose. It is not conveying the actual thing in the code, but we may be writing too verbosely. We may be writing not concisely, right? And that can happen when we think. That only happens when our mindset is of the fact that the program runs is the end goal, right? You do not want to think that the program runs is the end goal. The fact that the program runs has to be step one, right? So this is something called language equivalence fallacy, where programmers in general, think that multiple languages across spectrum are actually very similar. A lot of you may have heard or may have said, as I spoke on the first slide, that if you know Java, you can learn C++ very quickly. A lot of time people will say something like this, right? It's all syntactical difference, right? You know syntax of one thing, you can learn the other thing very easily, right? Now that is again, somehow underestimating what a new language offers to you, within its system, right? A lot of people never go beyond syntactical and semantic differences into other areas where the language can actually shine, right? For example, let's say a very simple case of doubling a list, right? Doubling a list, very simple. You have an array of numbers and you want to double the numbers one by one, right? Like again, if you have 2, 4, 6, and they want then 4 and 8 and then 12, right? So doubling a list. But if you actually come from, let's say, Java or C++ background, that's the language you have dominantly programmed in. And if you start programming something in Python, you would do something like this in Python, right? For people who are aware of Python and probably C++ and Java, right? You will take the list, and then you will have an I which begins from 0, and then you will have a while loop as you would do in Java, where you can have like C style for loop, right? It's I is equal to 0, I should be less than. Because Python does not have C style for loop, you accommodate that thing using a while loop, right? And then you do these sort of things, and then you return the double list, right? Now the thing is, this code is correct. This code runs, right? You can test it, by the way, right? In case if you want to later. But this code actually runs. This code will double the list, right? Double every element in the list. But for people who know Python, if I ask you to double the list, will you be writing this sort of code? Just raise your hand. Will you be writing something like this, like I is equal to 0, or would you take a different approach? Probably. Just raise your hands if you would take a different approach. Okay. A couple of Python people are saying that, okay, probably this is not the approach that they would be taking, right? Which is actually good, because the more time you spend in Python, you realize that there are better ways to do stuff, right? For example, in this case, because the list is something that I can consume in the for in loop, I can just say double list is equal to empty array, and then I can iterate in the for el, in ls, and then I can return the double list. I totally got rid of the I, right? Think about it. And I'm still doing the same complexity. I'm still doing the same performance. Nothing has changed, except my code has become shorter. My code has become more concise, and I'm telling what I'm trying to do, more concisely, succinctly, right? As opposed to a little bit more verbose version on the left, right? Now, this is something that is acceptable. But the more you learn Python, you're going to realize that probably this is also not the best way, right? So maybe if you know enough Python, you will actually go for the third option, which is using the list comprehension, where you are going to write something like that, right? Yes, and somebody says that you can do the same thing in C# with a link queue interface, right? Now create double list again. Now think about this. There are 3 versions, right? There are 3 versions of the same function, all of them doing the same thing, right? How many of you prefer the third version against the second version, for example? Okay. 10. Okay, that is good. 13, 14 people. You already have a preference of code. You already know that certain code is actually good, certain code is bad, even if they do exactly the same thing, right? And that is great, because that's exactly what you have to think about products, about everything in general, right? You have to just make sure that this does not really apply just to languages or expressions of programs in one language, but it applies to actually things in general, right? So let's take one more example, right? Just to kind of put this point across, well. Range is a function that is available in Python, and it takes 2 things, right? A lower bound and upper bound, and returns a sequence of numbers if the lower bound is not given generally from 0, right? So you can have a function range 0, 10, it will give you 0 to 9, right? That's a very, very common function. JavaScript does not really have it. So if you want to create a JavaScript function that is correspondingly similar to range in Python, let's say, right? You can try doing something like this, right? You can say, okay, I have this range function. There is a lower bound, there is upper bound. I have a result array, and then I go from lower, I go to upper, I do I++, I push each element into the result, I return the result, very simple. And then I can loop over this particular range, right? As many times as I like. And again, you can see that, while I'm trying to consume the range function, right, I actually put a really, really big number. In this case, what I've done is I have put an element size of 1 billion, right? So I want all numbers from 1 to 1 billion minus 1, right? Now, this is an okay range function. It also works, well sometimes. But the more you learn JavaScript, you will realize that probably this is not the best way to write range, because this is going to give you an error that is not even part of JavaScript, right? If you try to allocate a lot of elements, then you're going to get out of memory error because of the V8 engine crashing if you're doing it in Node, right? Or if you're doing it in some other, then the JavaScript engine will crash because it doesn't have enough memory, right? what you're essentially doing is you are allocating a really, really big array, and then you're returning the reference of that array, right? Like I said, the more you learn about JavaScript, or the more you learn about conceptual things like iterators and generators, you can probably come across another function like this one, which is the generator. It actually does exactly the same thing, but it doesn't have more than one unit of space. It never allocates an array. It doesn't have more than one int of a space, which is in JavaScript 64 bits, right? So that is all the thing you have right now, and it works exactly the same as the previous version without having the extra penalty of running out of memory, right? So again, same thing, but one code probably is better than the previous one, right? Let's take one more example very quickly. You can write something like factorial, right? And this is a recursive way of writing the factorial function, and this looks a little bit verbose, and you can write the same thing in Haskell like this, right? You can have, again, maybe the syntax is not actually familiar to you guys, but that's fine. What I want to show you is that there are languages where the verbosity, first of all, can be toned down a lot, and then they also have features that are not present in other languages, right? For example, in JavaScript, we don't really have function matching and pattern matching, which we do in Haskell. So we can match on the parameters that you pass to a function. So that is essentially the goal here, right? So Peter Norvig is director of research at Google, right? A really, really great guy. He wrote a book called Artificial Intelligence: A Modern Approach, right? Maybe some of you have read the book in your college. But he says that why is everybody in such a rush, right? Why do people want to learn a programming language very quickly, right? You go to somebody, you say, do you want to learn a programming language? And how much time are you willing to spend on it? They will be like, maybe 2 months, maybe 3 weeks, right? Maybe 6 months. Why is everybody in such a rush to learn programming, right? So some researchers and some engineers, in the book How to Design Programs, they say that bad programming is actually very easy, right? Idiots can learn it in days, even if they're dummies, right? And this is essentially talking about all the books where you have learn C++ in 24 hours. Have you seen those books? C++ for dummies, learn English in 90 days, or learn. Have you guys seen those sort of books where they have this premise that you can learn something really quickly, right? Sometimes even 24 hours, right? There is a book called Learn C++ in 24 hours, right? So I'm pretty sure some of you may have seen those sort of books, right? And the truth is that it doesn't actually happen. That's not how language works, right? If that were the case, then because you know Hindi and you know the grammar of Hindi, you know how to speak Hindi, or you know how to speak English, you can learn German very easily, because German essentially has 90% similarity to English grammar, right? But how many of you speak German? Or how many of you can promise me that they're going to learn German in the next month because it's very easy, because it's very similar to English? Maybe some of you actually know German, right? But did you learn it like 24 hours, 24 days, right? It takes time, right? It takes time to do these sort of things, right? So Alan Perley said that if a language is not changing the way you're thinking about programming, it's not worth knowing, right? So let me talk about this very quickly. The most bottom is syntax. A lot of people look at syntax and they're like, maybe this looks similar, right, to other languages, right? Syntax is something that is common. That is definitely true, right? Then you have semantics. What is the semantic of a certain language? That is something a lot of people do not really understand, right? Or they don't try to understand, but you have to also learn the semantics, how this language is actually different from some other language, right? Then comes the language philosophy. How is this language helping me model the reality in a certain way? Every language has a particular philosophy, and if you go into forums of those languages, you're going to learn about that, right? And then there are design principles that may be language agnostic. Techniques such as motivation, code, some of those things, right? So the most important point you have to think to understand mental box. The language serves as the framework in which you organize your thoughts. And if the language is actually not a powerful tool, then your thoughts are going to be limited to some extent, because you will not be able to actually have very grandiose ideas, because the language is not letting you express those sort of things easily, right? In case of English or other languages, you can think of not having the appropriate words to actually say those things. Why can you not talk about technical things in Hindi? Because we don't have appropriate words that correspond to the same thing in English, but we do in English, right? So English is in some sense not really like a very pedantic, but in sense has a little bit more power while discussing technical topics, right? Let's talk about the second thing, which is testing, right? And testing is something that is really interesting because a lot of people probably don't do it often, or everybody skimmed right on this testing thing, right? So again, identifying yourself. The first thing, I've heard a lot of people say, I am paid to write code, not tests, right? So that is one thing, right? That people say. I'm not going to be asking for raising hand because I'll have to kind of do this a little bit quickly, right? I'm a developer, not a tester, so I'm not responsible for writing tests. This is something that I've heard a lot of people also say, right? We already have tests. Why do we need unit tests? Again, something that I've heard. We are working on a tight deadline. My favorite one, right? We're working on a tight deadline. Where do I have time for writing unit tests, right? Or any other test for that sort. I don't know how to write unit tests. That's something else that people have said. This one's again my favorite, right? Ours is legacy code. Can't write unit test for things. If I touch the code, it breaks, right? And in fact, I have this conversation, with one of my students, right? So he was asking, what do you suggest if you're working on a deadline? Again, think about this really carefully, because I really want you to pay full attention to this, right? Like if you're working on a deadline, the guy asks, will you just think about the job to be done at the moment and do the refactoring later, or try to do the refactoring as much as possible, right? And then somebody says, if the deadline is tight, we'll try to finish the job, but we'll do refactoring later whenever possible, right? So one guy comes up with an answer also, right? And again, these are all actual Slack messages, right? I'm not making them up. So the answer is, okay, if the deadline is tight, right, we'll just try to finish the job, but we'll think about refactoring, doing things the correct way later, right? And then somebody else chimes in, says that, okay, it depends. If I have to take the call, I prefer to leave to-dos behind, right? 30 to 40% of the time, and I go back and refactor. And then the most interesting thing is that the guy from the original question says, what if I'm always working on a deadline and never get time to actually do refactoring? Now think about that. I just want to kind of make an analogy to some other field, right? Think about going to the doctor. The doctor is doing an operation on you, and the doctor leaves to-dos while doing operation. They're like, well, I had to cut this vein, or I had to fix this vein, right? But because I have to finish this operation in half an hour because I have another operation lined up, let me actually put a small to-do here so that the next surgeon can actually fix it. Do you think that is something would be acceptable to you? You would want your doctors and surgeons to actually not do all the things correctly because they're on a tight deadline? Just raise your hand if you would want your doctors to do that. I would let the doctors know, right? One or two people are actually saying they would prefer the doctors to not do quality work, but instead just focus on deadline, right? Good for you, I guess, right? Maybe you have that sort of doctor. But because nobody raised hands, I'm assuming nobody else raised hand, right? I'm assuming that they assume that the doctor is going to take full precaution, right? Even if the deadline is extending, I don't really care. You do the right thing, right? That's what you would want, right? And obviously, if the doctor is missing the deadline again and again, or if the doctor is not able to do something again and again, you would at one point of time ask them, what is happening, right? Why are you always doing bad things, right? So let me kind of contrast this thing with science, right? Very quickly, not an exact formulation, right? Just a very, very rough analogy to how softwares work. Now, you can kind of say that science is equal to theory plus experiments, right? Science cannot equal just experiments. It cannot equal just theory, right? You need both the things. A theory is essentially a model of the world, right? Okay, so for example, when you have theory of gravity, then you have a model. Okay, there is a massive object, there is other massive object, they attract. That's theoretical model, and then you do experiments to verify that the model works according, to the world works according to the model, right? And that's why you have the experiments, right? So experiments essentially ensure that the model is testable. And if you have a theory for which there exist no models, if there is a theory for which there exists no experiment, that will not be considered science by a lot of modern scientific understanding. For example, for people who believe in God, right? Like if the question is, if the hypothesis is does God exist, right? Now, this cannot be considered science right now, whether or not God exists, because there are no valid experiments that you can do to either prove or disprove this fact. So the only thing that can actually be science is the theoretical model plus the experiments that you can do corresponding to the model, and then you come to some kind of agreement, right? And again, like I said, not an exact formulation, right? So you can say in short that science mainly works by proving statement false by finding a counter example at times, right? For example, if gravity is not working, like the model of gravity is not predicting something correctly in one instance, right? Then you have to change the model because you have to take this thing into account, right? New thing into account. Then what is software? So I can parallelly say that, again, not an exact formulation, the code plus test is actually equal to software. Why? Because the code that you write essentially is a model of the world, right? The code that you're writing is the model, right? There is a model. As soon as you start writing the code, you create that model, right? In your head also, you have that model. The language lets you express that model into computer language, right? Into computer software. And then the tests is essentially the testability of the model, right? The more number of times you run the test and it runs correctly, you know that the model that you have conceived as an engineer is actually correct and there is no deficiency in the model, right? So if you just have the code, that cannot be considered software correctly because there is nothing to check whether the model is going to be correct over time or the model is even correct right now, right? You require both the things at all times. There are a couple of different ways to kind of do testing, right? You can do this thing in two ways. You can do static analysis, right? And dynamic analysis. Static analysis essentially contains things like type checking and linting. And dynamic analysis actually means running the program to find errors, right? Like running the program against a test suite and then finding things, right? So linting is essentially a process of running the program that analyzes your code for potential errors, right? So for example, in this screenshot, you can see that I probably didn't really define the word 3, the variable 3 somewhere. So I get this error without even running the code that 3 is actually not defined. It prevents these sort of errors, unused and undefined variables. So again, a very low form of testing. Linting is a very low form of doing tests, right? Not extremely important, but it is there, right? It can tell you about unused and undefined variables. It can tell about anti-patterns that you're using in your language, right? It can help you maintain standards such as nomenclature and spacing, etc. There are a lot of other things that it can do, but I would expect that you guys now search on this on your own, right? Then there is something called static type checking, right? Where you ensure that the operations are correct across the language. As in, every time you have an operator, the left hand and the right hand operations are actually correctly typed, right? Which means that if you have a plus, then you know for a fact that both of them have to be either strings or both of them have to be either numbers, because the plus is probably only defined for those two things, right? So that is essentially type checking. And a couple of errors that you get because of type checking is this sort of errors, right? So if you ever think to yourself, does this function throw an exception or return 0 or -1 or null? If you're not sure whether the function throws an exception or does one of these things, it is because you are lacking in types, right? You are probably not typing your code correctly or in a good way. The second can be if you're getting null pointer exception, or in JavaScript you're getting this sort of error, cannot find x of undefined. It is because you are lacking, you are not correctly typing your code, right? You can remove this type of exception by ensuring that the code is correctly typed. In fact, there are languages like Rust and Haskell which do not have the concept of null to begin with. And because they don't have concept of null to begin with, there is no null pointer exception, right? So this function was supposed to return an object. So sometimes you're like, wait, this function was supposed to return an object, right? You're not sure what it returns. Sometimes you're like, okay, this was not supposed to return a particular thing, right? So type checking essence, you know that it is checking types. You can use languages like TypeScript to check. Here is a very small example. You have add. You say that I received numbers. You pass strings. It throws an error. Right? Unit testing. Some of the things that you can do in unit testing is essentially this, right? You can say that the function is too hard. Why am I getting the wrong value, right? Unit testing is the process of testing the smallest individual component of an application. So in this case, again, we have the sum function, right? And I say, okay, the sum of 1, 4 should be 5. So if you're ever thinking, okay, why am I getting the wrong value, or okay, this function is probably too hard to test, then probably that's a deficiency in unit testing, right? Integration testing is actually very important. You can have a lot of unit tests, but the unit can actually work correctly without the integration working correctly, right? So that is something that can happen. So in integration testing, what the sort of errors that you can actually get is like this, right? If somebody comes and says to you, I changed file X and now Y doesn't work. I don't know why Y doesn't work, right? But I didn't even touch the Wi-Fi. If somebody says something like that to you, you know that it's an issue in integration testing, because integration essentially means making sure that two things work correctly together, right? You can see these two things where you have this example of chain, where chain is used to show that things are actually correct, right? End-to-end testing is the final one. That is, when I hit my API from Postman, and this is something that you probably hear at times. When I hit my API from Postman, curl, it works, but it doesn't work when the user submits the form, right? So you have this issue, right? Like the API is working when you are using command line tools, but it is not working when you are doing things from the interface, right? That means that there is a deficiency in end-to-end testing, right? And you can have techniques such as Cypress and other like Puppeteer, or right now you have other tools like Selenium, right, which is an old tool. You can use these things to actually test your application from the perspective of a user, right? To essentially do this, right? So at this point, I think I don't have a lot of time, but okay. So Prashant, I just want to very quickly, would it be okay if I'm taking 10 minutes more? Would you guys be okay?
Yes. So I think largely we're in a situation where you can take your time. So we're at 4:44.
Right.
You can take about 7-8 more minutes. Then we'll.
Right.
I think what we can do is we can avoid the questions, and you can take the questions offline. And at the end you can just share your email ID. They can send you the questions offline. So then you can take a proper 10-12 minutes, and I'll just wind up at about 4:57.
Makes sense.
All right.
So cool. Let me just take like next section is again not. It doesn't really contain a lot of tech things, right? But it does contain a little bit of product engineering. So essentially, these are some of the testing frameworks you can use, right? So the UI testing is essentially end-to-end testing. You should have some end-to-end test, right? You can have a lot of integration tests, which essentially means it's on the service layer, and then you have a lot of unit tests, right? A lot of people nowadays also say that, okay, you should have a lot of integration tests, few end-to-end tests, right, or some unit test. And then there is also this trophy sort of a structure where the trophy stand is made from static analysis like linting and type checking, right? But again, you can choose any one of these things, right? Let's talk about product engineering very quickly. Nothing, tech is here. Like, again, it doesn't really involve languages per se or other tech things, but yeah, it talks about product engineering in general. Right? Some of the things that you can use to identify yourself, I'll think of the solution design later. I'll plan how to proceed later. I'll get more clarity as I start coding, right? These are some of the things that you say to yourself when you are in the programming mindset, right? My goal is just to make sure that it works. Being a tech zealot, right? Like making sure, is saying that, okay, no, I will just be using Java or C++ or JavaScript. I'll document it later, right? This is one of the most important things a lot of people actually have in this, where you are like, okay, the first rule of programming, if it works, don't touch it. How many of you have seen that sort of things, right? It's a fairly common meme that you see, a lot of places. But the thing is, it speaks about the programming mindset more and more, because if you're not supposed to touch it, how will you modify and maintain and extend the software, right? So this is not something that I totally agree with, right? If it works, good. If it doesn't work, touch it. If it works, still touch it, right? No reason not to be afraid of the software. So a couple of things you can do to ensure that you are doing product engineering correctly. You have to think about higher standards than what you're thinking right now. Why do you need higher standards? If something is worth doing, it is worth doing well, right? Don't ever think that, okay, because just that you're doing something, it means like it's not probably worth doing well. No, just because you are putting time and effort, it makes sense that you should do it the best way you can, right? Doing things well is really enjoyable. You get, when somebody praises you for doing things correctly, it is enjoyable. You get, good things. And if you do something poorly, even if you have spent all the time, people are going to complain and you're not going to feel good, right? Building something that goes unused is really discouraging, right? You build some really cool application, but because it is very hard to use, people don't come to your application. And that is very, very discouraging, right? So you have to think about this from a product engineering perspective. How to develop higher standards? First of all, high standards are domain specific. You cannot have high standards. You cannot know high standards of everything in the world, right? You have to talk about higher standards of your own domain, front end, back end, full stack, DevOps, whatever that may be. Right? You have to learn from exposure from other good people. We're going to talk about that. You also have to be realistic about how hard some things are, right? A lot of people overestimate or underestimate what estimation in kind of engineering is. You don't need skills yourself to actually recognize high standards. Just like you don't really have to be a chef to know that the food is good. You don't have to be like a professional interior decorator to know that the house is well built. You don't really have to have the skills to know that something is actually higher standards, right? So first thing you can do is actually set your standards at a global level. If somebody is doing something, let's say, and it is common across India, doesn't mean it may be the best technique. You may go across the world and see, can I do better, right? So set your standards at a global level as opposed to just a national level. Right? Learn from the best. There are tons of things in the world. For example, the whole source code of React.js, Webpack, Python, everything is open source. You can go ahead, start checking the source code, start learning from the best of the best. How these things are built, right? How these things are architectured and everything. Attention to detail, really important, right? In this case, attention to detail is something, if you don't have it, people are going to feel bad about using your application. For example, you do not have loading indicators. In this case, this is a invoice page of Stripe, right? Even though it is demo page, right? It is just for marketing people, right? People who are not engineers, they still have taken care of extreme detail, because you click on these things and the price actually changes in real time, right? So they have put that kind of attention, even for people who are not developers, right? Fewer features, but do them right. You can see that Google's front page is just one search bar, right? And 2 buttons. And yet Google is the most viewed website in the world, right? You don't really need tons and tons of feature to make something correct. In this case, make higher standards a habit. So you can see that in this case, right? This is something that we took actual picture, right? In one of the Uber things. I don't know what happened, but somehow the printing was not correctly done in both of these cases, right? And that's essentially not acceptable if you want to go to a global standard. Right? Take the extra effort, or make the extra effort. You have seen these things, right? When people come to paint your house, how many of you have the issue where they paint over the sockets, or some of the paint go over the board, right? And that is absolutely nuts, because think about this: you can just put a tape over there and paint over the tape and remove the tape, right? And then you have the socket and the board clean. But a lot of people would not do that, right? Because again, they don't have higher standards to match. Right? Just this section, the cost of change. So if you're not planning ahead, the more later you actually do decide to do a change, right, the more it is going to cost. So this is NASA's cost escalation chart, right? If you find an error at the design phase, it probably cost you $1,000, right? The more further you go towards deployment, and then you find an error, the more it is going to cost, right? And the order of magnitude is actually 10, which is 10 to the power 1, right? Like it increases by a factor of 10. So if you find something in the final production distribution stage, then you are going to take that much more money to actually fix that error, right? So it makes more sense economically and time wise to actually have a good design and fix it before you actually release it to deployment, right? So this is essentially talking about the exponential growth of cost of change that happens when you are doing with software. You can have requirements analysis, and if you are able to figure out the bugs in requirement analysis phase, and during the coding phase, you're good. But if you go out, you have built the product, and the manager comes to you and like, oh, this is not correctly done, then it takes a lot more time to undo some of the work that you have done, right? Some types of error that you can have: code bugs, misunderstood requirements, building something that no one cares about. We have done that a lot. Bad user experience, bad schema design. For example, this thing looks really nice on the schema, right? You have a nice rectangle and then 2 small urinals, right, side by side, and it looks like, okay, this can actually work, but then this is just misunderstood requirements and bad user experience, right? You can also build something that no one cares about. I'm pretty sure a lot of you may have read about this thing called Juicero, right? This thing got investment of $120 billion, and then people realize that you can just press the juice pulp with your hands, right? So building something that nobody wants. Some tips on how you can catch errors early. Do testing, definitely, right? Test-driven development, for example. Whiteboarding is really essential if you want to make sure that you have the architecture of the software or utility that you're describing in place, right? so that you're not thinking of the architecture while you're coding, right? Wireframing in a team, wireframing either on pen or paper or balsamic is a very good way to ensure that everybody is on the same page. Otherwise, 5 engineers are going to have one conception of the design, the other 5 engineers are going to have other conceptions of design, right? And then there's going to be a lot of friction between them. Talking to customers is really important. Read app store feedback, ask a friend for feedback, help with customer support, do user studies, right? All of these things are super, super important, right? So that is all in cost of change. And if you are doing these things, then you have these things done, right? So Prashant, that was all from my side in product engineering, right? You can take over.
All right, fantastic. I think firstly, I think I'd like to point out that not one person dropped out. Everyone stayed through the entire webinar. So to all of you, thank you so much for doing that.
Thanks a lot, guys.
I think it was such an engaging session. Yes. So I mean, let me just sort of get across one question that came in, because I think you might enjoy answering that too. As a developer, the crux of our working is solving defined problems for users. But as product engineer, you need to think the other way around, which is identifying the problem also.
Right.
How do you approach understanding a business user problem statement? And how much of a critical role does empathy play towards your user in this process? I think this question comes from the point of view of how you've transitioned towards the product side. So, how does one work on this?
That's a very, very good question, actually. So you are a developer, and our mindset is that we are given a defined set of tasks, and then we continue doing that thing, right? But the more you actually go towards product building, you have to now take a couple of different stakeholders' opinions, right? So first of all, obviously you have this the user base, right? And before you talk to anybody else, you have to talk to the user, right? The user of the thing. It can be other developers, right? You have to do surveys, you have to do customer reviews, feedbacks, blind tests, right? Like A/B tests, sort of a thing on users. Before you even talk to your developers, you have to talk to the users, because if the users are actually doing these things, doing things in a certain way, then you have to listen to them, right? Even if, for example, if the users are saying that, okay, I want the payment to be done in cash on delivery, and Amazon famously didn't have cash on delivery in US or in London, right? But when they came to India, they realized that users want cash on delivery. And it doesn't matter whether you have a really, really strong payment structure. Even if you're returning something, right? Even if you have very strong trust, you still need to do what the user wants, which in this case can be cash on delivery, right? So again, you have to be empathetic with the user, and you have to talk to them. And then you talk to the company, and then you bring a lot of data points. Okay, for example, you can do surveys of 100 people, and the 100 people say, out of 100 people, 99 people say, or 90 people say, we want cash on delivery. That's a very good case against payment systems like card, at least in India, right? So data-driven approach from the user to the stakeholders, which is the company, is the way to kind of go about developing a product. Nilesh is asking, as a developer, I know the requirements. I had written the best code, debug my code line by line. So why should I have to write in the test for the same function? That's a good question. Nilesh has asked a very important question. I have written the best code, debugged my code line by line. Why should I have to write the unit test? Okay, let me answer this question like this, right? Right. So you go to a doctor. The doctor gives you a couple of medicines. Do not tell you the medicine. Mixes the medicine, gives you a pouch. You eat it. You are not you are not fixed. Like, okay, the doctor says, I gave you the correct medicine, right? Just wait for 6 months. It will work. Right? Would you want to wait? Right? Won't you want to know what did you give me? Right? How can I know that this is what you gave me? Right? Can I cross check with a different doctor? The purpose of test is not to ensure that the code is correct for you. You wrote it, you know it. It is for other people, right? The code is the test is never for you, right? If you ever do a medical test, the receipt is not for you. The receipt is for the doctor, right? If you give an examination, the paper is not for you. The paper is for the examiner to evaluate you, right? Don't ever think that you're writing tests for yourself. Think that you're writing tests for the next developer. They will agree. They will know that it is correct. The fact that you debug the code was in your head, and the moment you left the company, the code, the knowledge went away. Now I am coming to the code. How do I know that the code is correct? Tell me, Nilesh, right? Yes or no? I think that hopefully should solve the problem.
Perfect. So I think we're at 4:58, so I'll just quickly do my thank yous.
Okay.
We've
Fair,
just
I
did
think-
it. So I've left the YouTube channel link in the chat as well. And if there's any more questions, quickly, what's your email ID, Arthur?
Yes. Sorry, my email ID. I'll just write very quickly. Arfat@pesto.tech.
Right, perfect. So he shared that as well. And so you can write to him directly as well. And apart from that, we're already in conversation with him to get him back on board for another one very, very soon. Because I think you've all received some wonderful insights today. Arfat, thank you so much for doing this. I thought it was a great experience. Not one person dropped out, so I can tell you everyone who glued in were engaged throughout. Right. Right. So Siddharth Singh says, please get him back. Yes, Siddharth, we will get him back. Perfect.
Yeah, and there are a couple of questions. And the thing is, you guys can reach out to me on LinkedIn or Twitter,
Yes.
and then I'll be more than happy to engage in the conversation there.
Absolutely. Thank you so much, everyone. Stay safe, stay home, and I wish you all the very, very best. Thank you so much, Arfat.
Thanks a lot, guys. Thank you, Prashant, for all of this.